Hi, welcome to TJC Physics. This is carrying on our series of videos about waves. Today we're going to talk a bit about standing waves. So we've looked at the properties of waves and how to describe them mathematically using concepts such as wavelength, amplitude, period, and frequency. Now I would like to turn our attention to one particular way waves actually combine with each other. When two or more waves pass through a single point in space at the same time, they add together mathematically using a concept called superposition, where you just mathematically add the waves. Visually, this can look very confusing. So I'm going to use an online app, and I'll include the name in the description of the video so you can visit it yourself and play around with it, that talks about what happens when waves on a string combine. This line you see here represents a wave on a string. Now I'm going to get the wave to start going down the string, and the wave is moving to the right. So it is a transverse wave. You can see that the particles that make up the string there, the black dots, are moving up and down transverse to the direction the wave is traveling, is to the right. One other thing I'd like to point out here, I'm going to go back to slow-mo to talk a bit about it, is that the end of the line, right at the far right there, is fixed end. It can't move, it's tied down. So when that incoming wave from the right hits the end and the end can't move, in order to deal with the energy and momentum of the wave, it has to go somewhere. It will reflect back towards the left. I'm just going to clean up the diagram here, and I'm going to put it back to normal speed because I want you to see what happens as this wave is moving to the right, hits the end, and starts to reflect backwards. Okay, so what you were seeing here then in blue is the reflected wave going back, and the incoming wave is in red. By the way, you can try this by having a friend hold one end of a string or rope and you making waves going down at the other end. You will see that waves get reflected back. Now you may be thinking, but I don't see two separate waves like this coming back. Of course, this isn't what you actually see on the string. This is a mathematical representation of the incoming wave going to the right, the reflected wave coming back to the left. So what does it actually look like when you add these two waves together? In other words, what would you see on the string? So when the incoming and reflecting wave combine, this is what you actually see. A wave that looks like this. Now, there are conditions for what happens with a standing wave, and we can talk about those maybe in another video. But what you're seeing here is what it looks like when both these waves combine. So this is what you would actually see. Hopefully you can also start to see why they call it a standing wave. You'll notice if I asked you, is this resulting waveform moving to the right or to the left? You'd probably look at that and go, it's not moving right or left. The particles are bouncing up and down, creating sort of a waveform shape, but it doesn't appear to be actually moving either to the right or to the left. So it's a wave, but it's standing still in a sense. It's not moving to the right or to the left. It is a standing wave. You may be wondering what those A's and N's mean on the line that as the wave bounces around. Well, wherever you see an N, you'll notice that the part of the string, the particle of the string there, doesn't move at all. It's fixed right on that line. N stands for node, and that is a part on a standing wave where the medium doesn't move, in this case, the rope. You'll also notice that wherever there's an A, that's where the medium, in this case, particle in the rope, seems to move the most. It's where the peaks and the valleys of the standing wave are. This is cleverly called an antinode. Not clever at all. So antinodes are the locations where the vibration is the most, and nodes are where there is no movement of the medium. The vibrations are basically zero. So to summarize, a standing wave is created when you have a wave moving in one direction, in this case to the right, and then you have another wave that's moving in the opposite direction to the left. And these two combine together to form a standing wave. And this is what we actually see when we combine them. We've used here a simulation of a wave moving down a piece of string, but note that this idea of standing waves can occur in all types of waves, from sound waves, seismic waves, water waves, even light waves. So it's not just waves on a string. Standing waves are a general thing that can happen with combining different types of waves. In a future video, I will show you though what standing waves have to do with music and producing various notes. So we'll see that coming up, but this was just been a brief introduction to standing waves, and thank you for watching, and have a great day.